All right, let's talk about network troubleshooting. In this explainer, we're going to crack open the command line and take a look at the absolute must-know tools that every single DevOps and cloud engineer has in their back pocket for when things inevitably go wrong.
Picture this. It's 3 a.m., the pager goes off, alerts are screaming, a critical service is completely down, and guess what? Everyone is looking at you. You get that sinking feeling of, okay, where do I even begin? That exact moment is what we're going to tackle today. Because having the tools is one thing, but having a method, that's the real key. So let's take this list of commands and actually turn it into a powerful, logical workflow, a process that you can use to solve pretty much any network mystery that gets thrown your way. And our first step is always checking the absolute basics. Look, when trouble strikes, your first move isn't to come up with some complex theory about what's wrong. Nope. It's to ask the most fundamental question there is the machine I'm trying to reach even on and connected to the network? And that is where our very first command, ping, comes into play. You can think of it like shouting, hello, into a cave and waiting to hear an echo. It sends a tiny little packet of data to a target, like google.com, and then it just waits for a reply. If you start getting those replies back, you know the server is online. But if you see packet loss, well, that means your hellos are getting lost somewhere out there. And that response time? That's your first clue about how healthy the network connection really is. Now, just because the server responds to a ping doesn't mean your application is actually working. That's a good start, but it's not the whole story. See, applications listen on specific ports. You can think of them like a door number on an apartment building. Telnet lets you go up and knock on a very specific door, like port 80 for a web server. If the connection is accepted and your screen goes blank, you're in. The service is listening. If it fails, then the problem is probably with the app itself, not the network. Okay, so the server is on, and we know the service is listening, but things are still super slow. What gives? Well, the problem might not be at the start or the end of the journey. It could be somewhere in the middle. So now, we need to trace the actual path our data is taking. And for that, Traceroute is our digital map maker. It shows you every single hop, basically every router, your data passes through to get to its destination. It lists them all out in order and shows you how long it takes to make each jump. If one of those hops is suddenly really slow or dropping packets, you'll see it plain as day. And if you see a line of asterisks instead of a time, that's a huge red flag. That hop isn't responding at all. Now, for an even more powerful view, we've got MTR, which stands for My Traceroute. You can think of this as Traceroute on steroids. It basically combines Traceroute and ping into one single continuously updating dashboard. It just keeps sending packets over and over, giving you this amazing real-time view of packet loss and latency for every single hop along the path. So here's the key takeaway, the real difference between the two. If you need a quick, one-time snapshot of the path, boom, use Traceroute. But for those super frustrating intermittent problems, the ones that come and go, MTR is your absolute best friend. You just leave it running and it'll catch the problem the very moment it happens. So we've checked the machine, we've checked the path to the machine. Now let's kind of turn our focus inward and look at the server itself. Who is it actually talking to? And how much data is flying back and forth? It's time to monitor the traffic right at the source. Netstat is like asking the server, hey, who are you talking to right now? It gives you a list of all the active network connections. You can see which local and remote IP addresses are connected, what service they're using, and the state of the connection, like is it established or just listening. This is perfect for making sure your app is accepting connections like it should be, or for spotting any weird or unexpected activity. So while Netstat shows you who is connected, iftop and nload show you how much data is moving. These tools are awesome. They give you a live, real-time dashboard of your bandwidth usage. If your server suddenly feels sluggish, you can run one of these, and you'll know instantly if your network connection is just getting totally swamped. The difference between them is actually pretty simple. You use iftop when you need to do some real detective work and see which specific IP address is hogging all the bandwidth. And you use nload when you just want a quick health check. It gives you a simple, high-level graph of the total traffic going in and out of your network card. So far, we've looked at tools that have very specific jobs. But, every good toolkit needs a multi-tool, right? Something that's flexible and powerful for all those custom jobs. Well, for networking on the command line, that tool is, without a doubt, Netcat. Netcat, or just NC for short, can do a wild number of things, but for troubleshooting, it is a fantastic port scanner.
For example, running nc-vz example.com22 is a super fast way to see if the SSH port is open and listening. It's often much quicker than Telnet for a simple check, which makes it a huge favorite for automation scripts and just firing off quick tests. Wow, okay, we have covered a lot of ground and a whole lot of commands. But here's the thing, the real skill isn't just knowing what each command does, it's about knowing how to string them together into a logical, effective process for troubleshooting. And here is how it all comes together. This simple 4-step flow will solve the vast majority of network issues you'll ever face. First, you ping it to see if it's even reachable. Then, you use Telnet or NC to check if the service port is open. If you're still having problems, you use Traceroute or MTR to inspect the path. And finally, you pop onto the server itself and use Netstat to see what's actually going on. This structured approach takes all the guesswork out of the equation and gives you a clear, repeatable process.
You see, these aren't just commands, they're instruments. They turn network complexity into clarity. They give you the visibility you need to diagnose issues methodically, moving you from that state of confusion to confident, decisive action. So now, with this toolkit at your fingertips, what problem are you going to solve first?